resistance. Okay. Now, see, there are two type of combination of resistors. First one is series, and the second one is parallel. What is the difference between series and parallel? I'm going to write it. See, series, and here it is parallel. In series, I is same through all resistors. If resistances or resistors are arranged in a wire, and there is a resistance in wire, if current is flowing through current is flowing same through each resistor, that means I is same in series resistance. Now, what about potential V? That remarks potential difference, PD. I also call it PD, potential difference is different. And what about parallel? In parallel, I is different. That means current is different in parallel, and potential difference is same. This is the basic difference between series and parallel resistor. Is that clear?
Yes, sir.
Now see, I'm going to give you some questions regarding how to calculate equivalent resistance. Write a question. Calculate. Also, how to calculate equivalent resistance in series. R equivalent will be equal to add all the resistance like this. Dot, dot. This R equivalent will be equal to sum of all the resistance. And how to calculate equivalent resistance in parallel? What I told you, that 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus this. And you can easily calculate the value of R equivalent. Then you will get a equivalent resistance in parallel. Always remember that this R equivalent in series, R equivalent in series will be always greater than the individual one. Will be always greater than the individual one. That is understood because just suppose three resistances, 1 ohm plus 2 ohm plus 3 ohm. This will be the R equivalent, and you can see R equivalent will be equal to 6 ohm. This R equivalent will be greater than individual one, any individual one. You can compare it by R1, R2, R3, R equivalent. This will be greater than each of them. But when it comes to parallel, since this is reciprocal, this R equivalent will be smaller than the smallest individual one. What I am trying to say is that if you are going to take again 1 ohm as R1 and 2 ohm as R2 and 3 ohm as R3, can you calculate it? Anyone? Can anyone calculate this? Sarah, Harsha, and Abdullah.
Yes, sir.
Just please solve this. Find the value of R equivalent.
Okay.
6 by 11.
6 by 11. That means basically you can see R equivalent is equal to 6 by 11, right?
Yes, sir.
Yeah. So what I want to say is that in parallel combination, the equivalent resistance or equivalent resistance will be smaller than the smallest individual one. That means the smallest is 1 ohm, then 2 ohm, then 3 ohm. That means the 3 ohm is the largest one, and you can see R equivalent is basically 0 point something. So basically in parallel resistance, the R equivalent will be smaller than the individual smallest one. And here, if you are going to see in series, the R equivalent will be larger than any of the individual one. Is that clear?
Yes, sir.
Yes, sir.
Abdullah, Sarah, Hamna. Okay, I'm going to give you a question. So here is the question. Calculate the equivalent resistance. The first one goes like this is 2 ohm. This is 1 ohm and this is 2 ohm. Calculate the equivalent resistance. And this is also 2 ohm. Not forgotten.
Sir, in the parallel resistor, is it 2 or 8?
This is basically 2. You were talking about this, right? This is
Yes.
2 ohm, 2 ohm, 2 ohm. Sarah, your paper was on Wednesday, right? How was it?
It was good.
It was good, very good. Please send the paper to me, your unit test paper, okay?
Sure.
And if anyone have previous year's paper of your class 10, please send it to me. Whatever it is, unit test or final. Harsha, done?
No, sir, doing.
Okay. Hamna, Abdullah,
Yes, sir.
Sir, is it 9 by 2 ohm?
total
Yes, sir.
R equivalent. The first answer is 9 by 2 ohm. Any other answer or the same answer from anyone? Susie, I'm going to explain it. You can see current will emerge from here and it will go I and I. Now you can see there will be two paths. So here it will go I1 and here it will go I2. The I will be divided into two parts, I1 and I2. Now see, I2 is going through this and I1 is going through this. That means current is different in both this resistances. That means they are in parallel. Is this correct or not? These both
Yes.
are in parallel or not? Sa?
Yes, sir.
Very good. Now just calculate this separately. So what will be the R equivalent? You can see R equivalent will be equal to 1 by 1 plus 1 by 2. And you can calculate it as take LCM 2 and it will be 2 plus 1, that will be equal to 1 upon R equivalent will be equal to 3 by 2 and take reciprocal so that R equivalent will be equal to 2 by 3. I just calculated the R equivalent of this parallel one only. Now I'm going to make another diagram after solving this parallel resistances so that it will be more clear to you. Now going to again draw it to make it more clear to you. This is 2 ohm. Now after solving this 2 ohm and 1 ohm in parallel, it will become like this, and this is basically 2 by 3 ohm. And again, this is how much? How much this is? 2 ohm.
Ohm.
So it will be also 2 ohm. And you can see it's not necessary to for you to make another diagram. I'm just doing it for you to make it understand in a better way. This two parallel will be in now. See, I, 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 and again I. Now these three resistances are in series or parallel, Sarah? These three resistances, 2 ohm,
Series.
series. You can see because uh, I current, that means same current flowing through each resistances. That means they are in series. And what about R equivalent? Just add this 2 plus 2 by 3 plus 2. And you can see take LCM 3, and it will be 3 2 just 6. And then 2, and then wait a minute. Let it run. 3 LCM. So how will you solve it? Very. Harsha, is this
Yes,
your answer?
no, sir. I forgot taking the reciprocal in 1 by R equivalent.
Oh, that means here.
Yes, sir.
So you should take the R equivalent value. Now you can see if you are going to take LCM, it will be 3. So 1 3 is 3, 2 3 is 6, plus then 3 1 is 3, 2 1 is 2, and then again 1 3 is 3, so 2 3 is 6. So it will be 6 plus 6, 12 plus 2, 14 by 3. Is that clear, everyone?
Yes,
Yes.
sir.
Very good. If you are done with this, let me know, please.
Done, sir.
Done, everyone. Abdullah, Sarah, Amna,
Yes, sir.
Abdullah,
Yes,
Amna,
sir.
are you done?
Yes,
Very
sir.
good. Now see, I'm going to give another question regarding this. Calculate equivalent resistance, the B part of this. I'm giving you a very easy questions. Two ohm, 2 ohm, 2 ohm, 2 ohm, 2 ohm. Calculate the equivalent resistances. Please do this question. Hold on a minute. Am I audible?
Yes,
Yes.
sir.
Okay, any answer?
Sir, 10 ohm.
10 ohm. Abdullah, Sarah, and Hamna. Any answer from you?
So 1 minute.
Okay. One answer from Harsha, that is 10 ohm. Harsha, check your answer, cross check. If,
Okay,
okay.
sir.
I'll just calculate it, then I'll let you know what is the correct answer.
Sir, I think I did wrong. I'll just do it again.
Okay, just do it again. Abdullah and Sarah, any answer from you? See, I'm going to explain it. You have to do a lot of practice. You see, current starts from here. Now you can see I is going, but now I has three paths. So I will be distributed in three parts, I1, I2, and I3. So whenever there will be, you can see in which combination these 2 ohm, 2 ohm, and 2 ohm are connected. Is it parallel or series? Please tell me.
Parallel.
Parallel.
Parallel. So you just have to calculate parallel separately, so that after these three resistances will be combined in series. How you are going to do it? 1 upon R equivalent. This is very easy. 1 upon R1 plus, since three resistances are there, 1 upon R2 plus 1 upon R3. Now again, 1 upon R equivalent will be equal to 1 by 2 plus 1 by 2 plus 1 by 2. Now going to take LCM, 2 to 2, LCM will be 2, and it will be 1 plus 1 plus 1, 1 upon R equivalent. Now again you can see 1 upon R equivalent is equal to 3 by 2. Now see, what I want to calculate is R equivalent, not the value of 1 upon R equivalent. So R equivalent will be equal to 2 by 3 or not? Abdullah?
Yes, sir.
Yes, sir.
Abdullah, speak up. Yes, this is R equivalent. Now going to explain it again in the diagram form. You can see this is this one initial 2 ohm. Now this 2 ohm, 2 ohm, 2 ohm, 3 2 ohms resistor in parallel will become in series, and it has a value 2 by 3 ohm. And again this ohm, this all are in series now. Are you getting my point?
Yes, sir.
Now you can see these all are in series, and now you can easily calculate the series resistance, that is R equivalent is equal to R1 plus R2 plus R3, and you can easily calculate it 2 plus 2 by 3 plus 2. And again going to take LCM, 3 1 3 is 2 3 is 6, 3 1 is 3 2, 1 3 is 2 3 is 6, so it will be 14 by 3 ohm.
Okay, sir.
Yes, sir.
If you are not getting it, please let me know. I will give you questions separately, like in series, the resistances will be in series only. Then again another question, the resistances will be in parallel only. We are doing very easy questions, and now these questions will not only ask about equivalent resistance, but also ask about uh, what is the current flowing through this resistance, what is the current flowing through this resistance. It can be asked easily. Please do it and let me know. We just need to do a lot of practices.
Done, sir.
Sir, done.
Everyone done? Very good. Very good. Abdullah done. Hamna done.
Yes, sir.
Very good. Now see, I'm going to give you a very easy question. The same question, find the equivalent resistance. If we need to calculate, if question will be asked like what is the current in this type of resistor, then we have to know what is the equivalent resistance. This is very basic. That's why I'm focusing to calculate how to calculate equivalent resistance. So I'm going to give you some question like this. This is basically 5 ohm, 3 ohm, 2 ohm. Calculate the resistance, equivalent resistance. Please give your answer in chat box. I want answer from everyone. Everyone. Amna, Sara, Abdullah, Harsha. Amna, am I audible to you? Please drop a message in chat box. Any answer? If you are unable to get what I'm talking about, what is equivalent resistance, please let me know. I'll explain. Very good, Harsha. Sara, Abdullah, and Hamna waiting for your answers. Sara, should I explain it?
7 minutes.
Okay. Basically, the question is so easy. That's why I'm asking frequently. It should be solved within a second. If your concept is clear. If it's not clear, please let me know. Abdullah.
Sir, did you got my number? My answer?
No, not yet. I'm waiting in chat box. Maybe you have sent to someone else, like Learnivio OP. Very good, Sarah. Abdullah. Now see what are your what you are going to do if equivalent resistances will be asked. You have to see whether the resistances are in series or parallel combination. How we are going to see I with all resistances, same I is going. The same I is traveling or passing through different resistance. That means same current through each resistance. That means they are in series. And what we are going to do, R equivalent, take this R1, R2, and there will be R3. R equivalent will be R1 plus R2 plus R3, and this will be equal to 5 plus 3 plus 2, that will be equal to 10 ohm. It's so easy. Yes or no?
Yes, sir.
Abdullah.
Yes, sir.
Yes, sir.
Yes, sir. Only you are saying yes, sir. Very good. No problem. Abdullah, if you have any doubt regarding this, please ask me.
Okay, sir.
Okay, now another question. Hmm. What if it is given that this is R1, this is R2, calculate equivalent resistance. Calculate equivalent resistance. Whenever there will be asked, there will be question like what is the equivalent resistance, you have to see the resistances are whether in parallel or series. Then apply the formula and you will get your answer. If there will be no calculation mistake. Okay, Harsha, you made a
Sir, can
mistake.
you say again how to?
Whenever there will be question that asked what is the equivalent resistance, then see the diagram and decide whether it is whether it is parallel combination or series combination. Got it, Sarah?
Yeah.
And then you can apply the formula. If it is in series, you know the formula for series combination, and you also
Yeah.
know the formula for the parallel resistance, parallel combination, and you will get your answer.
Okay, sir.
Did I give you homework, Harsha? Sarah?
No, sir.
Okay. Today will be a home assignment from your NCERT. Please solve it. किधर हो? नहीं। क्या? ठीक।
Sir,
Every-
R1, R2 by R2 plus R1.
Wait a minute. Please tell me your answer.
R1, R2 by R2 plus R1.
Okay. I'll check it out. Any other answers? Who gave this answer? Harsha or Sarah? Harsha.
Yes, sir.
Sir,
Now see.
for me, it's like 2 by R1 plus R2.
Okay. Okay. See. Sarah, the resistances are in series or parallel?
Parallel.
Parallel. That means you can see I, and this will be divided into I1 and I2. That's why they are in parallel. Now, for parallel resistances, what we are going to do, 1 upon R equivalent will be equal to 1 upon R1 plus 1 upon R2, right?
Yes, sir.
And we need to calculate the value of R equivalent. So what we are going to do, simple mathematics, simplify. We are going to simplify it. 1 upon R equivalent will be equal to, going to take LCM from LCM from here. You can see R1 and R2 are different. That's why the LCM will be R1 R2. Yes or no?
Yes, sir.
Yes, sir.
Now see, you can easily see R1 R2 is the LCM, and since R1 is here, so R2 will be here, and R2 is here, so in this plus R1 will be here. Yes or no?
Yes, sir.
Now see, we are going to find the value of R equivalent. Just take reciprocal. R equivalent will be equal to R1 R2 upon R1 plus R2, or whether you can write R2 plus R1. Both are correct or not?
Yes, sir.
So this is the answer. What I told you is that whether you write R1 plus R2 or R2 plus R1, both are same or not? 1 plus 2 or
Yes,
2
sir.
plus 1, both are same. So the answer will be R1 plus R1 R2 upon R1 plus R2. Okay, please write it.
Yes, sir.
Abdullah, you got it?
Yes, sir. Understood, sir.
Very good. Should I change the slide? Moving to the next part of the question.
Yes, sir.
Yes, sir.
Okay. Okay, wait a minute. Okay, I'm going to give you another question apart from this. Basically, this is on Ohm's law. So the question is, write with me, an electric lamp wait a minute, please wait a minute. I'm going to
Sir, the question you're gonna give are same like before ones?
no, basically, it is about how to calculate resistances. Yeah, not resistances, current. Sorry. Are you getting my point?
Yes, sir.
Wait a minute, I'm going to do it in printed form if it is possible. It will reduce our time. Mhm. It will take time. Wait a minute. Is the screen visible?
Yes, sir.
Hmm. Please wait. Okay, it's not happening. I'm going to write the question. Okay, write the question with me. An electric lamp whose resistance is 20 ohm. And a conductor of 4 ohm resistance are connected to a 6-volt battery. Calculate A party's total resistance of the circuit. That means equivalent resistance of the circuit. B, current through circuit. Current through circuit. And C, total resistances, that is what? Okay. A, B, find the value of A and B. What is the C part? Okay.
Sir, how
And
will we know if it's in parallel or series?
I'm going to give you a diagram. Okay. I'll draw it. The C part, right? C part. Potential difference across the lamp and conductor. I'm going to represent a diagram like this. This is the resistance, that is 20 ohm, and there will be a conductor. This is bulb, and this is the battery. This is emitter. This is switch. This is 6 volt, and this is the basically representation. Electric lamp is 20 ohm. That means this is 20 ohm, and a conductor of 4 ohm. That means the conductor, the wire is of 4 ohm resistances. The potential difference you can see, a battery, that is 6 volt batteries. Now we have to calculate total resistances, current through circuit, total current, that means, and potential difference across the lamp. Can anyone solve it?
Sir, total resistance is the equivalent one, right?
Yes, yes. Total resistance is equivalent resistance.
Sir, I got the first one.
What is the answer?
24 ohm.
Very good.
Sir, we have to do like with the different equations, all those questions.
We need to calculate current. What is the formula for current? I have given you two formula. The first one with the definition of current, that is I is equal to Q by T in the first lecture. Do you remember it?
Yeah.
And the second, that is that comes from Ohm's law, that is V is equal to IR, right?
Yeah.
According to the situation, you can see R is given. You just calculated 24 ohm, and V is also given, that is 6 volt, right?
Yeah.
Then which formula we are going to use? This formula, Ohm's law.
Yeah.
The formula from Ohm's law, not this formula, because neither time is given nor charge is given. So according to the situation, we are going to use the formula. And for current, with the help of Ohm's law, I is equal to V upon R. Is that clear, Harsha, Amna, Abdullah?
Yes.
Please calculate it and let me know.
Sir, B part answer is 4 ampere.
4 ampere is very, very wrong answer. What you just did, we are going to current through circuit, right? So V is equal to IR and I is equal to V upon R, right? Then this R will be equivalent resistance. Are you getting my point?
Yes, sir.
This R will be, V is 6 volt now. What you just did, I think 24 by 6 you just calculated, right, Harsha?
Yes, sir.
And what is the value? You can see what is the value of V? 6, right? And what is the value of R? That is 24. You just inverse it, put the value wrong. Okay.
Okay, sir.
So this is basically 1 by 4 ampere, or you can see 0.25 ampere.
Yeah.
Okay, very good. Can I erase this? Abdullah, are you getting it?
Yes, sir. I'm getting it.
Okay, please write it and let me know. If you're done with this, then we will move to the next part, that is C.
Sir, completed also.
C you have done, right?
Yes, sir.
Okay, what is your answer? C, potential through each resistor across lamp and conductor. What is the potential through lamp? Potential difference through lamp. Sarah and Harsha.
You're doing.
Okay.
So the answer will be in volt, right?
Yes, it will be in volt. What is your answer for
5
4
volt
ohm?
for
5 volt
electric
for
lamp.
what? Electric lamp, right? Okay.
Yeah.
Okay, what is the potential difference for conductor 4 ohm? What you just said, answer will be 5 volt, right?
Yes, sir.
Very good. I just
So for conductor, how will we do?
in the same way that you did for lamp. See, current is same, right? I is same, and we are going to calculate V is equal to IR, right? V is equal to IR. I is same. I is basically 1 by 4. And what is the resistance here? 4. So here the voltage for conductor will be 1 volt. And in the same way, you are going to calculate it here. V is equal to IR. Current is same. That is 1 by 4. And what is the resistance? 20. So it will be 5 volt. Harsha,
Yes, sir.
I told you that in a series combination, the current will be same and resistances will be different. Is that clear, everyone?
Yes, sir.
And always remember that in a series combination, if you are going to calculate individual potential difference, and if you want to recheck and cross check whether the individual potential difference is correct or not, here you can see total potential difference. You can see the voltage that battery is providing is 6 volt. Is that clear? 6 volt. And now you can see 1 volt across this conductor and across this resistance, and 5 volt across this. Total how much it is? 6 volt or not?
Yes, sir.
So basically they are used, and they are almost equal. They are equal. They will be equal. Okay.
Yes, sir.
Okay, can I move to the next part?
Yeah.
Okay. Abdullah, Harsha, do you have any doubt?
No, sir.
Okay, very good. Now we are going to do another question. First, I'm going to write the question, not the question. I'm going to write the draw the diagram. So basically the representation is like this. You can see I current is going, and it will be divided into three parts: I1, I2, and I3. And also R1 is given as 5 ohm. This is 10 ohm, and this is 30 ohm. Okay, which have been connected to 12-volt batteries. This is 12-volt. Battery is 12-volt. And what we need to do is calculate the A part is current through each resistor. Current through each resistors. B part is total current in the circuit. And C part is total circuit resistance. That means equivalent resistance, total circuit resistance. Question is very easy. Total circuit resistance. That means equivalent resistance. Done, everyone?
No, sir.
No, sir, or yes, sir?
No.
Okay, see, I'm going to explain it. It's very easy. I'm going to solve the last question first. Okay, you can see total circuit resistance that I told you is equivalent resistance. Is that clear, everyone?
Yes, sir.
Now see equivalent resistance, and you can see 5 ohm, 10 ohm, 30 ohm resistors are in series or parallel?
Parallel.
Parallel. Then can't you apply the formula 1 upon R equivalent is equal to 1 by 5 plus 1 by 10 plus 1 by 30? Sarah,
Yes, sir.
can you solve this R equivalent?
Yes, sir.
Okay, please solve it and let me know the answer.
Sir, 1/3.
1 by 3, right? Any other answer? Harsha, what is your answer of R equivalent?
Same, sir, 1/3.
Okay, so I'm R equivalent is equal to 1 by 3 ohm. You can see. Now see, total current in the circuit. Total current in the circuit. You can do it by A, B, C. It's so easy. And B part is total current in the circuit. That means V is equal to IR and I is equal to V upon R. Now you can see V potential is given 12 and total resistance. If it is asking that total current, then you have to apply equivalent resistance, total resistance. That is basically 1 by 3. 1 by 3 it will be or not?
Yes, sir.
Sir, you are doing the first one or second one? A or B?
B part. Wait a minute. Okay. B is basically total current in the circuit. Wait a minute, let me see the first question. Current through each resistor and then total current in the circuit. Okay. Is this correct? 1 by 3 ohm. Let me solve this. 1 by 5, 5, 10, 30. LCM will be anyone?
30.
30, right?
Yes, sir.
It will be 30. 5, 6 is a 30. 10, 3 is a 31 is a 30. R equivalent. Now, if you are going to add it, R equivalent will be equal to 10 by 30. Again, you have made a very big mistake. That is, you just told me that R equivalent has a value 1 by 3, right?
Yes, sir.
Sarah and Harsha, have you realized your mistake?
No, sir.
No, sir. What I asked you is value of R equivalent. R equivalent. And what you told me is the value of 1 upon R equivalent. Harsha,
Yes, sir.
got it, Sarah? Sarah?
Yes, sir.
So R equivalent has a value that is 3 ohm, not 1 by 3 ohm. Okay. Is there any
Yes,
difference
sir.
between R equivalent or 1 upon R equivalent? Yes or no?
No, sir.
No, sir. There
Yes,
will be
sir.
difference between R equivalent and 1 upon R equivalent. Yes, Sarah?
Yes, sir.
So you both gave me the wrong answer that I trusted. 1 by 3 ohm. The value is 3 ohm. Okay. Now see, B part is basically asking is what is the total current. So R has a value, total resistance 3. So total current is 4 ampere. Is that clear?
Yes,
Yes,
sir.
sir.
Now see, A part, calculate current through each resistor. What I told you is that in parallel resistances, potential are same and currents are different, right? So
Yes,
if
sir.
the circuit has 12 volt, that means this will also have 12 volt. This also will also have 12 volt, and this will also have 12 volt because these are all in parallel. So I'm going to apply V is equal to IR. That is I is equal to V upon R for all the
Sir,
resistance. Yes,
in series also they will be same, right?
no. In series, current is same, potential difference are different. See the notes. Harsha?
Okay, sir. Understood.
Okay. I is equal to V upon R for this resistance. V is basically 12 and R is 5. You can divide it. In the same way, you are going to I is equal to V upon R. V is 12 and what is the resistance? 10. And again, I is equal to V upon R. V is 12 and R is basically 30. And you can easily calculate it. It will be 1.2 ampere. And here you can see 2.5 to the 10, 0.54 the 2.4 ampere. And here you can see uh, 3 4 ja, 3 10 ja, that means 2 5 ja, and 2 2 ja, 0.4 ampere. And if you are going to add this individual current 2.4 plus 1.2 plus 0.4, it will be 4 ampere. So what you have to keep in mind is that in series, current is same, potential difference is different. In parallel, current is different, potential difference is same. Is that clear, everyone?
Yes, sir.
Okay, please do it. And I'm giving you some questions from exercise. Please solve it and send it to me. If you are done with this, let me know.
Done, sir.
Okay, please.
Done, sir.
Okay, write the homework. From exercise, okay? So from exercise, you can see question number 1, question number 4, question number 6, question number 8, 9, 10, 11, 13, 14. This 2, 4, 6, 8, 9. 9 questions from NCRT exercise. Okay.
Yes, sir.